For this problem, we're going to rationalize some denominators. In other words, we're going to get the radical out of some of these fractions, out of the bottom of these fractions. And for the first problem, we have negative 2 over the square root of 3. How do we get the radical out of the bottom? We just take the original question and we multiply by the square root of 3 over the square root of 3. This is the approach when we have a single radical in the denominator. Just multiply by that denominator radical over itself. Okay, simplify. Of course, on the bottom, you're going to get the cancellation of the square root and just get the number 3. So the bottom is just going to be 3, and our answer is negative 2 times the square root of 3 over 3. Now, of course, you cannot cancel the 3 under the radical sign with anything outside of the radical sign, so this is finished. Okay, part B, we're going to simplify the square root of 2 over the square root of 8. Okay, we're going to rationalize the denominator specifically. So what I want to do is, first I'm going to simplify. There's a couple of ways you could do this problem. I'll just show you this way. If you know another way, go ahead and use it. You can go ahead and bust up the bottom as the square root of a perfect square 4 times the square root of 2. And then the square root of 4 will simplify to 2 in the denominator. Okay, now we can simplify the square roots, and we got 1 over 2. And for the last problem, we have the square root of 3 over the square root of 5, and then minus 2 outside of the radical. Now, that's very important that you notice that minus 2 is not under the radical sign in the denominator. We have the square root of 5 as one term, and then from that entire square root, we're subtracting the number 2 that has no radical sign on it. Okay, the point is we have 2 terms in the denominator of this fraction. Not one term like the previous two, part A and part B. Here we have 2 different terms separated by that minus sign, and at least one of them has a radical in it. At least one of them. They could both each individually have radicals, but here we have one of them. Okay, so when you have 2 terms in the denominator of a fraction, and at least one of them has a radical, the way that you simplify that is that you take the original question and you multiply it by the conjugate of the bottom over itself. Now, look at guys, you've got to make sure that it's over itself. In other words, don't be putting a plus sign on one of them and a minus sign on the other one. When you multiply this original question with a fraction, that fraction has got to be equal to 1. In other words, the top has to match the bottom. Otherwise, it will not be illegal for you to say it's equal to the original question. That equal sign would be invalid if you hadn't done that. So be very careful to have the same value on the top as you have on the bottom. Continuing, multiplying on the top, square root of 3 times parenthesis, square root of 3 plus 2. On the bottom now, we're going to use a formula. Because on the bottom, look what we have. Conjugate times conjugate. So we're going to do first dude squared times minus second dude squared. So it's the square root of 5 squared minus 2 squared. Okay, on the top, we have square root of 3 times square root of 15 plus 2 in parentheses over, okay, simplify the bottom. We get 5 minus 4. Okay, so that gives us the square root of 3 times the square root of 15 plus 2 over what? Over 1. 5 minus 4 is 1. That's why you see nothing in the bottom. Now, that's my answer. Some of you say, well, shouldn't you distribute that multiplication? Well, sure, you could if you'd like. If you distributed it, you would get the square root of 15 plus 2 times the square root of 3. But I really don't consider that any more simple than what we have here. This answer is sufficient enough.